Hello, my name is Jason Burrow, and for my project I was doing river wing dike construction. In my presentation I'm going to be talking a bit about how are they built, what purpose do they serve, how does this management strategy work, and how effective is this management strategy. And also, what are some of the real-world examples? They can be built from a variety of different materials, the most common being stone, but in the past they've also been made with different materials like timber, concrete, and sometimes sandbags. They are typically built perpendicular to river flow to help try and divert some of the water flow away from the bank. So the size can vary on a lot of different things. The main reasons being the material, so if it's, say, rock, it's much less prone to being broken up and washed away, as opposed to if you were to use dirt to build the dike. There's also a big difference depending on how big the river actually is. If it's a wide river, you're going to need a much longer dike, and you're going to need a much bigger one if the actual depth of the water is deeper as well. So what kind of a purpose do they serve? There's a few different reasons why you would want to build a dike, and a few of them being to manage river flooding. So this is more so for smaller rivers, because depending on the size of the river, the dike's effectiveness will vary. If you have a bigger river, then it won't do as much to prevent flooding, but in the case of a smaller river, the dike can actually hold back some of the water, which doesn't give the river as much of a chance to overtop its banks. They can also help to manage sediment distribution. Because they're protruding out into the water, these dikes can actually trap a lot of sediment, which helps to rebuild the banks. But at the same time, it increases water speed on the other side of the river, which in the case of a large river can help to keep the riverbank relatively low, allowing for ships to actually go through and use it as a path. Same way that they help prevent sediment from forming on the bottom of the river, they actually help to trap the sediment as well, which stops the banks from eroding quite as much and helps to build them up. Diverting flow also goes hand in hand with the sediment distribution, because they divert the flow to the middle or the far side of the river, allowing it to kind of cut down and the riverbed relatively low so that ships can use it. By putting in a dike, you get a series of different benefits from it. So reduce flood damage. So by helping to slow down the rate of the flow, it helps to prevent the river from overtopping its banks by holding back that water. It reduces a lot of the flood damage that could be caused if it were to overtop its banks. So the initial cost of putting in a dike is much cheaper than what it would cost to actually repair the damages if it were not there in the first place. The effects of a dike are minor compared to many of the other strategies. You won't need to spend as much money on dredging to clear out all the extra sediment that would be there otherwise. A real-world example of this would be the Mississippi River. It's so large, it's gotten a lot of use out of dikes, and it's made it much easier to navigate ships throughout the river, and it has also made the river easier to control. The effectiveness of dikes decreases with the size of the river, meaning that more rock is used to actually create these dikes throughout the Mississippi River. Because of the amount of rock that's used to actually create these dikes in the river, the water levels have risen quite a bit. This leads to a lot of displacement of water in the river itself, which has led to higher flood levels in the area,